which recursively defined function represents the sequence 2, 4, 10, 28, and so on. The first statement is that f of 1 is equal to, and f, this is a plus 1, so next term is 3 to power the term which is before f of a minus 5. So let's check the first statement. So we have f of 1, so first term is 2. It's okay, we have 2. F of next term, so after 1, so will be 2. What will be? We have to use now this formula to find the second term. What it is 3, we copy. The term before f2 is f1, so it will be 3 to power f of 1 minus 5. So this is equal 3, we copy. F of 1 was given that this is 2, so we have to replace f of 1 by 2, minus 5 we copy. Next we have to first take to second power 3, so it will be 9 minus 5, so this is 4. Everything is okay, so second term is 4. Let's see if the third term will be the same. f3, what will be? We have to use again the same definition. So this is 3, we copy. The term before f of 3 is f of 2, so it will be f of 2 minus 5. So this is equal 3, we copy. F of 2, we calculate that this is 4. And we have minus 5. So this is equal 3 to 4th power is 81. Minus 5. Always first we have to do the power and next subtraction. So this is equal 81 minus 5. So this is 76. Our third term is 10. So for sure the first statement doesn't represent the sequence 2, 4, 10, 28, and so on, because the third term is different, 10 and 78. So this is not definition of our sequence. Let's check the second. First term is f of 1 is given 2, so everything is okay. So the second, what will be? We have to use now this formula to find the second term. So this is 3 times f of a. So the term before f2 is f1 minus 2, we copy. So this is equal 3 times f of 1 is 2. So it will be times 2, and we copy negative 2. So this is equal 3 times 2 is 6 minus 2 is 4. Second term is the same, 4 and 4. So we have to now check the third term. What will be? The same formula we have to use. 3 times f, the term before is f of 2 minus 2. So this is equal f of 2 we calculate is 4, so we have 3 times 4 minus 2, so this is equal 3 times 4. First we have to do multiplication, is 12 minus 2 is 10. Third term is the same. So let's see the fourth term. F of 4 is 3, the same definition we have to use. 3 times the term before, so f of 3. Why before? Because we see that the term a plus 1, so it's like next term, we have in formula that this is the term before. We have only f of a. And we have to subtract 2. So this is equal 3 times f of 3. We found that this is 10 minus 2. So we have 30 minus 2 is 28. But exactly the same what we have in our example. The fourth term is 28. So we can say that the second statement defined our sequence. This is correct. Let's see what will be when we take the third statement. f of 1 is equal to first term, and the second, the next, is defined by this formula. So this is 2 times f of a, so the term before f of 2 is f of 1, minus 5, we copy. So this is equal 2 times f of 1 is 2, minus 5, so this is 4 minus 5 is negative 1. Our second term is 4. So we see that is not our solution. And let's check the last statement. We have that first term is equal to, and the next term is defined by this formula. So this is 2 to power f of a, the term before. So f of 2 will be 2 to power the term before is f of 1. So this is equal 2 to power 2, because f of 1 is 2. So this is 4. The second term is 4. Everything is okay. Let's see the third, f of 3 will be 2 to power term before, so f of 2. So this is equal 2 to power 4. 2 to power 4 is 16. And our third term is 10, so it's not the same. So we check that only the second statement defines our sequence. The solution is second statement.